contact, 100% keen and modulation is go. 4, 3, 2, 1.
Hey everyone, glad to have you here everyone. Competing with the Java 9 talk is not an easy thing, so I'm surprised in a very positive way. I was talking at Global Azure Bootcamp a couple of weeks ago and I had the same time slot as the guy talking about Azure and Lego Mindstorms. And I had all these people coming into my room and I thought, wow, my topic is so much better than Lego Mindstorm. And they were coming in and grabbing the chairs and moving over to the other one. So. Glad to have you here. So yeah, as Klaus said, how to not fail with Azure, but the focus here is really not on Azure, so how to succeed with Azure, but I've been a developer, an operator, an architect for about 10 years, some eyewitnesses here in the room, and I have failed a lot, I really did. I did so much. But I learned from it, because every mistake you make, you usually don't make twice, or so they say. So I learned a lot of things during that time. But the funny thing is, when I started to look into Azure, I found so many best practices applied already for developers, for operators, for architects, and I wanted to share this with you. So yeah, what about Azure then? So I think I will start a little bit with a comparison. So what makes Azure different from other cloud providers, at least when it comes to numbers? So this, for example, is Amazon Web Services, a little bit of an overview of their regions, plus the number of services they have. So every icon here is for about 5, 6 services. So you see dozens of services available on AWS. Likewise for Google Cloud Platform, not quite as much locations, but still lots of services. And then there is Azure, so a little bit more locations. I think the number of services is pretty much the same like on AWS, maybe a bit more, maybe a bit less, whatever. Some specific information about Azure is that Azure has more cloud locations than AWS and Google Cloud combined. So chances that you will have a cloud location near you, for example, when you're living in New Zealand or something like that, is very high. Then they have dedicated regional clouds. So this means if you're a company that usually would not be allowed to go into the cloud because, you know, American enterprises operating the cloud, there is, for example, something like Azure Deutschland, which means this is an Azure data center operated by T-Systems, as far as I know. Microsoft does not even have access to the data center because it is operated by someone else. And this allows them to apply government rules and government policies that might enable you to deploy into Azure Deutschland, whereas you would not be allowed to deploy into an Azure instance in Northern Ireland or an AWS instance in Frankfurt, things like that. Plus, they're really focusing on the hybrid use case. So they will come up with Azure Stack sometime later this year. Azure Stack is Azure in your private data center. It's the same tech stack. It's the same software underneath, but just on your premises. As Klaus said, I've been visiting Microsoft quite a bit lately. So just so you have a little bit of a picture. So Seattle, Bellevue, Redmond, this is pretty much like Linz, Traun, Urfa. You know, it's all flowing into each other more or less. Microsoft is really headquartered up here in Redmond. And when you focus on that spot here, which is a bit larger here, so here we have Interstate 405. And most things here, so I just did a quick search for Microsoft on Google Maps. All what you can see here is Microsoft. So it's really kind of like first here in Linz. whereas first is even a bit more separated from the rest. But when you're driving through the streets of Redmond, it happens that the left-hand side of the road is condos and, you know, normal stuff. And everything to your right is Microsoft. And I mean, not just on that side of the road, but the rest of the city. So over 100 buildings, it's really big. Plus, Microsoft is in its third era now. That's my words, so don't quote me. The first era was Bill Gates. His vision was a Windows computer on every desk. After him came Steve Ballmer, who really put the enterprise focus on that. And despite popular belief, Steve Ballmer really added a lot to Microsoft. He really put that enterprise focus on it. I think it grew, I don't know by which faction, during the time Steve Ballmer was CEO of Microsoft. And now it's the third era with Satya Nadella. He used to be the cloud CEO, and he's now, as all of you are aware of, I guess, CEO of all of Microsoft. And his mantra is, use whatever technology you want, and you can run it on Azure. The talk from Rainer, just the previous session, he showed us Bash on Windows, .NET on Linux. They really don't care anymore. Their major focus today is selling Azure compute resources. That's it. They really don't matter what, as long as you run it there. So from a mindset perspective, should you go for Azure? Should you not go for Azure? I think that's kind of like the same discussion, just like should I go Java or .NET? As a developer, I have always been more of the Java guy. I just didn't feel comfortable with having everything out of the box. I wanted to look up my own library for whatever. I didn't want to use the one that comes with the framework, which is very often the case with .NET. I always felt much more comfortable with Maven instead of NuGet, things like that. But Azure is really, as I will show you, is really for everyone. So you do not even need to be that Microsoft-minded guy or gal. It's really just for everyone. What is the cloud? The cloud as such is just another data center, as you know. It's just someone else's computer. But it's designed to be very self-serviceable. You can spin up VMs, shut down VMs, stuff like that. But one very interesting way to think about it is the cloud is not where you run it, but how you build it. To really profit from the cloud, you have to apply your software architecture to the specific advantages that cloud providers offer for you. If you're happy with on-premise, if you do not want to do it, just don't. I mean, you're the one who knows your environment the best. But the cloud use case only really starts to make sense when you have a couple of issues, like if downtime is downtime. If downtime is not really an option, you know, there's lots of small shops in the internet. Well, they go down for an hour, they go down for the night. Yeah, it's really not much of an issue. But if your environment is too big to handle manually, the cloud should be really an option. If you want to scale anytime, if you want to scale at a very high granularity, you should really start looking into it, because all these mechanisms I will show during this talk lead to a much lower total cost of ownership than if you would run it on your premises. I will have some stories about how I failed and where the cloud would have helped me. So let's start how I failed as a developer. Developers, yeah, Rocket Man, right? So how did I fail as a developer? Well, I didn't really. Of course I did. But the thing was, when I look back, very often when I failed, I didn't fail because I failed intentionally, but because I just was not aware that there was a better way of doing it. So for example, who here is a developer, or who of you ever had a development environment open on his machine? Okay, so who of you is convinced that version control like Git or whatever makes sense? So let me tell you, that was not really the case about, let's say, 15 years ago. Well, 15 years ago maybe, but not 17 years ago. You would kind of argue, with some people about it because it's so much overhead. We have floppy disks we can use for synchronizing our code, stuff like that. Same for dependency management. When you start out with something like Maven or NuGet, as a developer, it's probably, you cannot just start coding and write your hello world. I mean, you can write your hello world, but when you add dependencies, the overhead of having to create that Maven file, anyone not aware of what Maven does or what a package manager does? Okay, so who is convinced that we do not need dependency management? Who is convinced that we do? Okay, good. So it makes it easier for you. Let me show you Azure Portal. So this is Azure Portal. No, it is not. Just a second. All right, here we go. So I will feel sick after a minute because of all the looking back and forth. Oh, I have it here, great. So this is my Azure Portal. So I have all my resources listed here. And for example, you cannot just run virtual machines on Azure. You can just deploy your web app to Azure. You know, that jar file, that war file, that NuGet package. You can just take it, publish it to Azure. You don't have to care about the web server that's underneath, not the software part, not the hardware part. You just deploy it. And this is possible because you use all the dependency management stuff. So let me just pick one. So here we have that web application, Martin's Moments, which is really this web application here, just some picture uploading thing. So this is just to show you this is real. I'm not going to demo anything really. Here we have our IAM. We've heard that in the first, I think it was the first breakout session today. And here we go. Here we have deployment credentials and deployment slots. And oh yeah, I'm on a, I'm really cheap. So you could go with different deployment slots as well. I don't have to configured. But what I really want to show you is deployment options. Here we have it. So this web app has been linked to my GitHub account, to a GitHub project, to a certain branch. Whenever I push something to the branch, Azure recognizes automatically, and there's lots of other platforms that do that as well, but Azure is my example here. So I have my, let's say, release branch in GitHub or wherever. I have this web application linked to that, and it does all that automatically. Plus, I can add deployment slots. So I can have slot 1, slot 2. Slot 1 is in production. Slot 2 pulls the latest update. I can do my canary tests. We've heard about that already today as well. If everything works fine in slot 2, I switch over between 1 and 2. Load balancers now go to slot 2. Slot 1 is not in production anymore. So I can do that automatically in Azure without having to set up whatever mechanisms on my private infrastructure. Oh, by the way, we can make this as interactive as you want. So I'm pretty sure Klaus would be happy to grab his microphone and visit any one of you if you have any questions. But unless there's no questions, I will just keep talking until Klaus mutes my microphone. All right, back to the presentation.
I can't mute you.
You can overthrow me or however do they. Yeah, I'll show you that in Azure I just did. So I should have told you about you. So this is for me just some, milestones because I tend to forget things I wanted to say, and after the presentation I would have known so much better. So we are all on the same page. You need a version control, and not just because you need it for the sake of the tool, but it makes sense for other tools that can easily pick up your work. Something about open source, it kind of slipped in here. If you go in open source, share your code from the first check-in. Don't wait for, I have to tidy up my code first or whatever, but forget it. So use dependency management, we've had that. Do unit tests, continuous integration, deployment automation. All these things are not only here to, let's say, improve your quality or your workflow, but it also makes it much easier for you to integrate with other tools, infrastructures and stuff. So that was for as a developer. So how did I fail as an operator, and how would this been easier in the cloud or in Azure specifically? I once installed MongoDB manually. So I grabbed the binary package from the server because I needed that latest minor version, not because I really needed it because of a fix or whatever. I needed it because it's me, you know. I don't work with old stuff. So the distribution only came with, I don't know, 2.4.6, and I really wanted 2.4.11 or whatever. So I downloaded it. I executed it. So it wasn't even the Debian package or the Red Hat package or whatever. It was really the tar gzip file, right? I unpacked it, and MongoDB out of the box runs. It assumes you have certain defaults, and it runs. And one of the default options is it only listens on localhost. So I was doing that on the server. I was trying to access it from my workstation. I think I spent 2 hours. It was his server, by the way. After 2 hours, I pinged him. I said, hey, man, what's up with your firewall rules? I cannot access my Mongo. I said, no way. We use the template, you know. They do things automated, right? So I tried to convince him that his firewall rules were broken. He did some command line magic and showed me very quick that I go by default so that I only listen to localhost instead of wherever. So if I had installed it from at least from the package, there would have come a default configuration file at least where I would have seen this default value. So, but I did not. I spent an afternoon, I bugged him. He's still talking to me though, so it wasn't that bad, I guess. So I really failed here, and if you have that as a service, there isn't even the question about where should your server listen to, because it's designed for the cloud, it is deployed on the cloud, it's clear that you will need remote access here. Another thing, again, a database server. I was working with a very proprietary SQL database, still SQL, but very proprietary. And when we had to set up the server new, I had to look for that license file. And the fun part was I didn't only need that one license file, I needed another one because the license we bought was for version 10, then we bought an upgrade for version 12. But the upgrade path was when you reinstall, first you needed to go with version 10 and then you had again to upgrade. So you couldn't just start with the upgraded V12 license. VMs were not that established back then, and so we were doing this on bare metal. If we had done this in a virtual machine, it would have been so much easier because we could have had a pre-configured image having that stuff. Plus, VMs also run on your own bare metal stuff, so you do not even need to go to the cloud for that. So that was also spent lots of days like that. And then when I first started playing around with the cloud, all I did was setting up a VM, and I was wondering, okay, what's so cool about it? I've been running VMs for a long time, so what gives? I'll show you on Azure what running a VM on Azure could help you with. So there is one thing, I think we heard it earlier today, infrastructure as a code, again, my friend here, who had a talk earlier today about that. So, and Azure comes with infrastructure as a code built in. Admitted, Microsoft did not build on something that was there already. They created something new, which is called Azure Resource Manager template. So Azure Resource Manager is the name of the architecture Azure is built on. And ARM is the abbreviation. And ARM templates allow you to define your infrastructure as a code. And you can click on pretty much any resource you have, and you will find this automation script entry here. And Azure will automatically generate that automation script from you. So they are not ready for being pushed into production again. So you will need to do some tuning and tweaking here and there, but still it gives you a very good starting point, because a VM is not just a VM after all. There is your CPU size and memory size, and that's only the simplest things. You have disks, you have network interfaces, you have firewall rules, all kinds of things. You might have user management, things like that. So all this can be configured here in a ARM template. And this makes your life so much easier as an operator because it allows you to replay any tasks you need to redo very easily. All right. And we're back, right. So I should have told you the following. Yeah, you should really know, so to not fail as an operator, you really should know how to spin up your whole environment as a whole from configuration files. You should really run on VMs. I think you really should. Nobody has 4-core physical servers anymore, so you probably have that 16-core, okay, one. But maybe even there. You should really take advantage of that virtualization layer in between, even if it's your own hardware. Even if you do not really see what use it has, but just that automation feature you get out of it helps you so much. You really should go that way. And of course, check whether databases or queues or whatever stuff you're using aren't available as services in the cloud. So when we go here again, you can click Add New Resource. Let's look a little bit database. It's easier here. So we have Elastic. We've had a talk about that before earlier today as well. SQL, MySQL, hosted either by Microsoft or someone else on Azure Cloud. So all these companies actually are earning money because when you decide to use the Teradata Enterprise, whatever here, the resource counter for Teradata on Azure will run, you know. So Teradata will be happy if you run their stuff on Azure based on their offering. So this is, yeah. So check whether your database isn't available here. It might be easier, it might not, but still it might. Okay. Yeah, and don't just run VMs in the cloud. Don't just do lift and shift because that makes no operator's life easier. Only services really do. I will talk a bit about that in a couple. Questions so far? Klaus is getting tired. Okay. How I failed as an architect. I picked the brain here for depicting architects. Not sure whether everybody gets the connection, architects and brains, but still. So once we wanted to add MongoDB to our project. The problem was that operations didn't want us to because they said, who should run it? So this is also a problem you would not have in the cloud because the cloud runs it for you. So the operations team was very established, very well established, very skilled people. It was just they didn't have any knowledge about MongoDB at all. In that case, we were really lucky because later, so MongoDB was really hot at that time. We thought we can just use it for anything. Turned out it wouldn't have been the right case anyway, so it was good we were not able to do it, but still. So I learned two things. For one, don't run for every hype, and two, yeah, cloud helps you in getting away a bit from that vendor lock-in. Another thing, me and a fellow architect, yeah. So we decided. So we were working inside the same enterprise, and we were designing two solutions, which had kind of a very related user target group. So there was my application, there was his application, and we were talking over a coffee, and we decided it would be nice. So he needed some authentication solution, and I needed the same. So we decided, why not decide on the database schema together and then have both applications access the same database schema, right? Sounds like a great plan, and it was. It worked really well. Until some months later, I somehow forgot that their database also, that their application also accesses the database, and we upgraded the schema. The other application stopped working. The really fun thing was nobody noticed for 3 weeks. But still, so that's sharing databases and tables is not the cloud use case. The cloud use case should be a service-focused approach. So for one, today you would go for an authentication service anyway, but still if you decided to build something for authentication, you should make it a service with a database behind it, but do not really share the database as such. Plus I didn't look into any other concepts because I knew I wanted to know how all of that worked. So, okay, we need authentication. Sounds thrilling. Let's think about how we can do this. Yeah, we did it. But it cost us a lot of time. We learned a lot, but still it cost us. So, yeah, as I said, don't run for every hype. That's a bit of the downside for cloud, you know. It makes it so easy to try out new things, which is good, but you should really spend some time with new technology before you really decide to put it into production and to find out whether it really works. Of course, services, having small services, communicating via HTTP, TCP or whatever, makes it really easy for you to pick a different language for every service. But you should really focus on the human perspective here. You should not pick the best technical language for your solution. You should pick the solution your team is the most versatile with. Let's put it that way. There might be some performance critical things which require you to do it in a very specific way. But so we had, when I was at Dynatrace, we had one inquiry about whether we supported the programming language D. So, you know, C, C++, D. Because the solution they were working on really required them to do it in D, because that was the only language that fulfilled their performance requirements. Well, I think we all agree that that's ridiculous, because it's surely not. But still, if you are a PHP shop, do not force your whole team to move on to Java or .NET, for example. Or if you are, well, yeah, I think you got it. Cloud is very closely tied to microservices, as I said before. You should really build on the advantages a cloud has to offer. So read and try to learn a lot about how this works before. So there is one book, Domain-Driven Design. It has been misinterpreted a lot, and I have suffered a lot. Eyewitnesses in the room again, smiling now. But there is one chapter in, and the author himself said, unfortunately, it's chapter 14 and not chapter 2. It's a bounded context. A bounded context decides how you define your object model. And this is really key. So if you manage to have a clear object model, objects for every domain in your application, even if there are overlappings, then you are very, very well suited for refactorings later on. If you want to share functionality, make it a service. Take care, it should not be just a CRUD wrapper. It should really be a service, but that's the way to share functionality. So I said before, the cloud is not about where you run it, but how you build it. So how do you actually build your system so it becomes cloud? So for one, I think behind all this is one very, very important thing, and this is you have to think about human scalability and not so much about the technology, about scaling the technology. What I like about microservices is that if it's done right, it can help a small team of 3 people a lot, but it can also help enterprises having teams, let's say the 2 pizza-sized teams, right? So up to 4 or 5 people. It can help you a lot. It is just like with Maven, for example. You have to do some work up front. You have to do some of the setup. You have to do some of the configuration. But if you're working on a monolith, after 2 or 3 years, you will come to the point when you try to pick up one ball, the other one is falling down, and you try to juggle 3 or 4 balls in your hands, and picking one up, another one falling down. And this is where microservices really come in handy. you cannot produce a bug on your web interface because you were working on the billing system and the bug exists because they were working with the same object. That must not happen. And this is where microservices, or at least the microservices mindset with bounded context, really comes in handy. So think about human scalability first. If something feels wrong, think again. This is not black-white. You might be there 80%, but maybe not 100%. So take your time. Bounded context, I said that already. Read a lot about microservices. Really read. Netflix has blogs. SoundCloud has blogs. Elastic has blogs. All these microservice companies have blogs. There is lots of not so good information in there because, to be honest, they mainly use this as a hiring resource to present them as good employees. But still, there are, so the blog posts that deal with the mindset and how they got there, they're really very, very, very interesting, and you can really take a lot of them. Yeah, and practice. So you really should practice it. So start with something small, not critical. So my favorite example is I was working on an e-commerce platform. So, and one of the functionality was you have to send emails, right? But for different reasons. You have to send out an email if an order comes in. You have to send it to the customer. You want to send the email to the shop owner because maybe something fails, then at least there should be the email notifying him about the order. You want to have emails if a new user is registered. You want to have emails to your operators if something fails, stuff like that. So there's multiple spots in your applications where you want to send out emails. And what we did back in the day was we had some components, and each of that component had that Java mail dependency in, and every application, every service had to kind of implement the SMTP part of Java. So that, for example, would be a great candidate for a first microservice. It's not critical. Nothing will really stop running if emails are not sent. But you would have all your email credentials in one spot. You wouldn't have your Java mail dependency in all your projects. So if you need to do an update to a library and that library is just used in that one service, that all becomes much easier. Yeah, and don't fix what's not broken. I could spend an hour talking about that. Big bang refactorings, just for the sake of it, turned out to be not really successful. So I've been talking to a customer of ours just yesterday. So they have a monolithic PHP application, and some parts of it work well, and some parts of it will require refactoring. So especially the UI part works fine. And I told them, okay, keep the UI part in PHP. Just don't change it. There is no reason for it because PHP renders HTML, and in HTML they have all their jQuery stuff. It works fine. But what you can do is substitute the direct database calls from your PHP code, make them separate services. You can even take your PHP code and deploy it as a second PHP service and have this do the database call. And then you introduce that interface between your UI part and your database service part. And this interface, if it is well defined, you can replace both components all the time without breaking the other component, because the interface keeps your system stable. So that's really very important. So if you need to do refactoring, don't just refactor everything for the sake of it. Besides that, yeah, be a team player. Really be a team player. Don't be whatever else. There is no I in team, at least I thought, but there is. Yeah, I found the I in team. Finally, I found it. It's here. It's in the A-hole. So enough said. Productize. Whatever you need to do on a regular basis, try to productize as much as possible. Even if you are a project-centric team, even if you are working from project to project, regardless of the project you're working on, try to productize your flows. That means setting up your development environment, setting up your integration environment, setting up production environments, publishing, testing, continuous deployment, integration, automation stuff. We've heard a lot about that today. So this is really not so much focused on the cloud, but this is really the way to be fit for the future. But still, don't over-engineer. So yeah, so disclaimer here: automate everything, but don't over-engineer. Easy, right? Yeah, don't reinvent the wheel. Build upon what's there. There's lots of concepts like platform as a service, buses, gateways, storages. So for example, application gateway is a very interesting concept. An application gateway can be mistaken as being just a load balancer, but it's really not. An application gateway is the one instance that gets all the requests, let's say from your website, from your mobile applications or whatever. And based on the request that is coming in, say /user whatever, /customer whatever, /product whatever, based on the URL that's coming in, the application gateway forwards the request to the according service behind. So you do not even take care about how to spread your requests among all your microservices, just in case you're doing the microservice stuff. So yeah, service buses, PaaS, there is something for everything, believe me. I'm pretty sure you can really, so today is really the time when you can focus on your business logic. There is no need anymore to build all these things yourself. I'm really convinced about that. But of course, you will need to do research, and you will need to read a lot. So that's it so far from my side. I think we have 6 minutes left for questions and answers.
That's correct.
Thank you.